Welcome, good people. My name is Joel Collier, and today we're going to talk about 5 underused functions in AMOS, the structural equation modeling software program. So there's, a cornucopia of functions in AMOS. A lot of them in the icon ribbon on the left-hand side, many more up in the menus at the top. But I want to talk today about 5 what I call underused functions in AMOS, which are really extremely handy functions that oftentimes kind of get overlooked and really can kind of help you create models quicker and can be beneficial in actually just interpreting your analysis. So I'm going to talk about 5 functions that's going to kind of help you kind of progress along in your data analysis. So let's jump into it. Function 1. The first function is preserve symmetries. So this icon looks like it's got 2 double-headed arrows that are red with it looks like kind of an indicator that's getting kind of moved kind of in the icon itself. And it is located on the icon ribbon that's on typically the left-hand side of the screen. So let's jump into AMOS and we'll kind of show you exactly what this function does. So I've got a simple model here where I've got a independent leading to a dependent variable, and it's got its measurement properties included. So let's say I wanted to move the adaptive behavior construct here. And so if we use the move objects property and I click that, well, it's going to move one at a time. And I've seen kind of countless students when I'm teaching structural equation modeling, they'll be doing this and they'll move them one at a time up to the top, and it's just kind of a hot mess. And it's, wasting a lot of time kind of doing this too, especially if you have a very large model. Well, what preserve symmetries does is instead of just moving kind of one object at a time, preserve symmetries kind of let you group objects. And so, like for instance, if you wanted to move, well, it will move everything that's grouped with it. So with adaptive behavior, if I select this preserve symmetries icon right here while the move button is selected, now if I click on adaptive behavior, that unobservable construct, and then just drag, you can see I can move the whole thing. I'm not moving one object at a time, I'm moving everything that's attached to the adaptive behavior unobservable construct. And as well, if you wanted to, let's say, well, I don't like where the error terms are too far away. Well, then if you use preserve symmetries and you do the move function, you can see I can move all of them out, in. Let's say your indicators are, too close together. Well, I can just move them apart. Or they're too far apart. Let me move them back in. You want them closer together. I want them closer to the unobservable. I want them farther away so I can see. And so what it does is it allows you to group objects. So when you're moving those objects too, it makes it easier to kind of reorganize a model on the screen instead of moving one object at a time, from the from just the move function. Now another one you can do with preserve symmetries too is the this icon called changes shape of an object. So if I click that instead of move, and I'm like, oh, that adapt one, I really want that box bigger. Well, see, if I drag this, see, now I'm literally changing all of the box shapes of all of the ones of the observable variables in here. I can do the same thing with error terms too. I can drag all the error terms to match kind of a consistent size too. So in case I had like E7 right here, it was really huge, but the rest were kind of small, well then I can go in there and hit that preserve symmetries button and then reshape the object, and then just reshape all of the error terms to be the same size. Same with the observables. And it's just kind of a quick way to do this with the preserve symmetries function used instead of doing them one at a time. Large models, you're talking, could have 50 plus indicators in there. That's a lot of movement and a lot of time. It's just unnecessary. Function 2. Function 2 is the drag properties function. The icon for that is basically these little small multicolored boxes with kind of a red arrow kind of pointing down, and it's located on the left hand side kind of icon ribbon too. So let's jump into AMOS and kind of show you the drag properties function and all its benefits. So drag properties, for the most part, is saying that I want some attribute of a single entity, let's say it's an observable or an arrow or something. I want those characteristics to be dragged to multiple objects, or to mirror this in multiple objects across your model. So instead of having to go in, one by one and change certain things, well, now I can use the drag properties function. So the drag properties, again, is that kind of multi-colored kind of boxes with the arrow kind of pointing down. And so if we click on that, we get a little pop-up window here that says drag properties. Some of the things that you can drag are height and width of a box or a circle. You've got parameter constraints, which is a really popular one that they use with drag properties. Font, if you don't like the font, maybe your entire model is in, like I just don't like it, I want to change it, you can change the font in a single, let's say as a single indicator, but then drag it to everything else in the model and change all of the font. Some of the others too that you'll see that's prominently used is colors, especially with arrows. Really big models, sometimes you'll see constructs where it's like maybe I've got multiple paths coming off of this single construct, or it's coming to it with multiple paths, and they just want to change the colors of those arrows so they can clearly see those within maybe a larger model with a lot of black arrows going all over the place. So this first example I want to kind of show you is just kind of height and width. So if we look at our adapt 5 construct right now, actually our indicator, the box is more like a square now and not a rectangle. And let's say you wanted to be like, I really want everything a square right now. I don't want to change everything. I don't want to change just the size of the box on just the adaptive behavior construct, because I could use that kind of preserve symmetries function. We could easily do that without using the drag function. But what if I wanted all of my indicators in all of the model to be that same size? Well, then we probably still couldn't use preserve symmetries, because it's only going to change kind of what's connected to it, but not kind of the whole model. And so the first thing that we need to do is we need to, if we're happy with this is what the size we want to drag, we need to select all of the entities we want to match those height and width dimensions. So let's say I want to change all of my indicators. I want them to all be the same height and width, and I want them to match that adapt 5. Now, one of the things that's really kind of, to be honest, a little kooky with AMOS, and it was really frustrating to be honest with you to start with, is the drag properties window has to be active for this to work. Now, right now you can see the drag properties window is up, and if I left click and drag adapt 5 onto any of these others, nothing happens. And I remember it was like, what is going on? Like, why won't this drag anything? Like the window's up, I see it, and I'm dragging and nothing happens. You literally have to click into the drag properties window. You see how it's almost kind of grayed out, but now if you click into it, it kind of comes kind of colorized again. So even if the window is visible, it doesn't mean it's active. So that's, again, a little bit of a quirkiness that you need to kind of know. So now that the window is active, that I clicked on it, now if I go to adapt 5 and I left click and I drag on to all of these, the next one where everything's kind of highlighted, look, everything changes. All of the indicators now have the exact same height and width dimension. So if I wanted to do this for all of them, I could just, make sure I got one of my boxes that I really, liked, and then I could change or highlight all the other boxes and then do the drag function. The other one that you see quite prominently that's used is what's called the parameter constraints. So let's say I wanted to constrain the parameters of all of the adapts, adapt 1, 2, 3, 4, and 5, but I wanted them to all be equal. And so the way that you do this is oftentimes you have to label all of those parameters the exact same thing, which denotes to AMOS to say, all right, these are all equal then. So if I go into adapt 5 and I just initially double click into it, and I want to change that parameter by putting in the regression weight, and I'm just going to call it something like A. All right, so I want that A to be basically labeled, and all of the other, you know, arrows, if you will, or parameters for the rest of the model. I want to constrain all the paths to be equal. So I've labeled this first one of DAP5 A, but I want to do this to all the rest too. So using the drag properties function, what we're going to do is we're going to check parameter constraints. And now we need to, after we've already got the constraint on the one that we like, we now need to highlight all the ones we want to drag to. And so you can choose those individually, or you can hold down your left mouse and just drag over those and it will highlight them. So now I've got all the ones that I want to drag to, and see again how that drag properties is visible, but it's not. It's kind of grayed out. It's not active. You need to click back into it, and now you've got an active window. So now I want to go to that first one where I constrained, and I'm going to drag that into the first highlighted one, and now all of those parameter constraints are labeled as A. So I constrained all of them. And it's just a quicker process than going in one by one and trying to label all of those. Now if you've got a small number of parameters to constrain, 2 or 3, you may be better off just going in, but if you've got a large number, oftentimes when you're talking about trying to test common method bias where you're constraining literally all indicators in a model, you're talking about a large number of parameters that has to be constrained. And so in this instance, you're in essence going to do it with just kind of a click of a button. The other thing that I want to kind of tell you about is, really kind of colors. And it works the exact same way as how I just showed you with parameter constraints. So if you changed, let's say, adapt 5, the arrow in there to be a different color, what you can do is after that one's changed, then just highlight where the arrows that you want to match, and then you can kind of drag down into that those highlighted arrows to change those colors. And so it's a handy little function, especially if you need to move or change or drag the properties to multiple things in your model at once. So instead of having to kind of, again, go in one by one by one by one, you can change large numbers of things very quickly with the drag functions property. All right, function 3. Function 3 is move parameter values. The move parameters function looks icon-wise like a circle, and it looks, to be honest with you, like a Greek letter gamma with arrows kind of either pointing it to the left or the right. And this function is located in the icon ribbon as well. So let's kind of go back to AMOS, and I'll show you exactly what this one does and why it's so beneficial. So we're back to our simple kind of independent to dependent model right here, and let's say that I have decided I'm happy with my model. I want to go ahead and run it. So I calculate estimates. But now I want to see the output actually on the model. I have the option of going to the text output, which gives me kind of all the details, but sometimes I just want to see just the output on the model. So if I go out here to the top and then to hit view output, you can see now that I've got these parameter estimates and loadings right here in my model. The problem though is now I've got, like for instance this one, it's kind of hard to see that parameter estimate. It's getting cut by an arrow, and then this one right here, all right, well, which one, 0.88, 0.87, just looking at them, it's kind of hard to tell which estimate is which. And the move parameter value function lets you move these actual estimates so that you can kind of see them a little bit better. So that again, the function is up here with this circle, which looks like kind of a gamma going left and right. So probably the easiest way for me to kind of see this is let's start moving some of these parameter estimates now in more of a little bit easier form for me to actually see. So now I don't have them kind of laying on top of one another. Now I can move that 0.92. I could leave that 0.90 kind of where it's at because it's still pretty easily visible, or I could move it up and be kind of consistent across so that I know that the estimates are kind of above the line. And maybe it's just like there's a lot of stuff going on right here and I don't want it right there. Maybe I just want it further down, or I want it further up, or I want it on this side of the line or that one. And basically what the move parameter estimate does is it allows you to see the information clearly, especially in very large models. Again, maybe you have covariances trying to kind of cut through there and you can't hardly see what it says. Or maybe you've got a lot of, kind of these estimates that are located in a very small space and you just need to move them around, because otherwise it gets real confusing to even say, well, what is that estimate? Without literally just kind of going into the actual text option. But if you want to see it on the actual screen and you want to make it kind of clear, the move kind of parameter values lets you actually have a better understanding of what that value is, and so that you're not trying to have errors sometimes even in reporting or even telling to others about what that estimate is, when in reality you just got too many estimates kind of jammed in some small spot and you just made a mistake. So moving those around can ultimately kind of benefit you and just kind of help prevent errors too. Function 4. Function 4 is the duplicate objects function, and the icon on that looks like a little copy machine. It's on the left hand side ribbon. The nice thing about this function is if you have a large construct with a lot of indicators, but you have multiple of those, instead of kind of creating them kind of one at a time, you can create one and then just kind of copy the functions. So let's go back to AMOS. So I've got a unobservable construct, but it has 8 indicators and 8 error terms. And so I could possibly go up here to kind of draw a latent variable, and I can do that, and I could draw 2 more of those. Let's say we had 3 constructs that all had 8 indicators. Or I can use the copy function. Again, it looks like a little copy machine right here. And if I go into the unobservable and I left click and just drag, you can see, well, we're already done then conceptualizing those. I've got all 3. And I'd probably need to move those indicators around to kind of save the center of the page for structural paths. But I've just now, instead of having to go in and click 8 times and move things around, I've got it exactly the way I want. The issue that you need to be mindful of, though, too, is if you have this construct and you label everything first and then do the duplicate objects, it will duplicate everything in there, including the wording, which you really don't want. There's really no reason that you would ever want to duplicate the construct wording too, because AMOS needs everything uniquely labeled. So really your duplicate objects function works best before you label it. Now if you do not have the preserve symmetries function engaged with the duplicate, what happens is then it will just duplicate whatever object that you drag off of it. But if I want like the entire thing, I want that whole construct with all its indicators and error terms, then I'm going to need the preserve symmetries engaged as well. And then when I use the copy function, well, then everything kind of goes with it as a complete duplicate. It'll save you time, especially with large models that have a lot of indicators. You can just use the duplicate function really quickly to conceptualize models out. Function 5. Function 5 is the specification search function, and the icon itself looks like binoculars. And it's on the ribbon on the left hand side as well. So what this function does is it's kind of if you want to think about it, a little of the opposite of what modification indices do. So modification indices says that if I add a path between 2 constructs, will will it make my model better? Will it make it stronger in regards to maybe finding significance or even kind of model fit? Well, specification search is a tool that basically does the opposite. It says if I take away paths, what happens to model fit? So instead of me kind of one by one, like, well, let's take that path away and run it again, what happens to model fit? Well, okay, well, let's take this path away. What it does is it runs all these kind of multiple models of all kind of possible ones to see, well, what happens if you take away paths? Do you get better model fit? Usually you're looking at specification model search to kind of help with model fit. In essence, does your model fit the observed covariance matrix? And if you're having some issues with getting a kind of a good fit, one of your options is the kind of specification search function. Let's go back to AMOS now, and I'll show you how this kind of works. So I've got kind of a full structural model here. It looks like there's a lot of paths going on. So I've got two kind of independent variables, and they're leading to this term called customer delight. And from customer delight, it's going to tolerance to future failure and positive word of mouth. But I've also got these direct paths coming from the antecedents directly to the dependent variables too. So there's a lot of paths kind of going on right now. So to test this and try to see if we can get a better model fit, we can go to the specification search function right here. Again, kind of looks like binoculars. When you click that, you're going to get a pop-up window that's going to come up for the specification search. And these little kind of dotted lines here, basically if you click on this, it's going to say, all right, which one of these paths are you wanting me to possibly delete? So make optional, if you will. So if I click on those, you'll see the arrows will start to turn highlighted, but the default on that is pink. So you can see I've at this point made all of these arrows optional. So when I run my possible models, it will delete them. It will keep some. It'll look at all kind of possible ones. But also if you said, hey, like this path right here, adaptive behavior to customer delight, that has to be there. It can't go away. So there's no sense even running models with that. So if you click kind of this solid line, what it does is it makes it a path that has to be in the model. So it's not optional anymore. It says, no, this one has to be here. But for the sake of the example, what I'm going to do is I'm going to make all our kind of structural paths just optional at this point. So if we go to this little triangle on its side, it's the play button, if you will, and click that, it will run our specification search. And it does it really quickly. Let me kind of make this bigger for you to see as well. So you can see it has had all these different possible models, all the way up to 44 different possible models. It will also give you the saturated model, which means that there's no degrees of freedom. They've put all possible ones in. You want to ignore the saturated model in this instance. It doesn't really help you. What I like to do too is I like to go up into the options on this, which is that kind of little box with a check mark on it. And I like to get a little bit more information. I just feel like the more info I have, the better. And what I like to click on is this kind of derived fit indices. And what it does is it just gives me more information. You can see here on the right hand side now that it's giving me CFI model estimates, and also giving me root mean square error of approximation, which I really like that one to determine kind of model fit kind of moving forward, because it's usually not sample size sensitive. So if I click on the root mean square error of approximation and just kind of sort these out, you can see the first at the very top is kind of the saturated model, and we're not concerned with that. The next one down though was model 44. So it was the 44th one. Well, how do I determine what's the 44th model? Well, if I double click into it, it's going to tell me which paths were taken away. So model 44 actually had no paths taken away. With all those paths included, you can see on my root mean square was 0.03, which is really good. It's below kind of 0.05, or it's kind of traditional kind of cutoff criteria. But let's say we wanted to look at the next best one, model 38. So if we double click into that, you can see now the adaptive behavior to tolerance to future failure, it disappeared. So it's the model basically with that path taken away, and it can show you kind of your model fit estimates with that path gone. Same thing if we go down to the next one, model 39, when we click that, well, now we see, that the path from ServiceScape right here to word of mouth kind of disappeared, and you can, see kind of the models and which one kind of fits best. And so up here you've got different options too. So this is chi-square, which is a C, or this is chi-square minus degrees of freedom with a C minus DF. And then you have other options for kind of model fit. To be honest with you, my own personal preferences, I like root mean square. I also like CFI. I find that those are usually kind of the gold standard with determining model fit, really. And so what this does is it allows you to determine what would my model be if it just took some away. But again, it runs it multiple times over in all the possible combinations of optional ones that you gave it to see, well, which one gives me the best model fit. Now, if I get out of the specification search window itself, it's going to ask me, hey, do you want to keep the model based on this, these changes right here? And if you say no, well, it'll default back to everything. Well, you notice it's still pink, and this is kind of one of the little quirkiness aspects of AMOS is you literally have to go back and tell AMOS, no, I want all of these not to be optional anymore, which is kind of clicking that solid line and then, basically going through there and making those mandatory lines and not optional. Otherwise, when you get out of it, even though you're out of the specification search and you said no, don't save it, it still has those arrows as pink. And so you have to basically go in and say no, don't make those optional, make them mandatory to kind of get it back to its original looks, if you will. So that's kind of the 5 functions. If you're looking for more information on AMOS and specifically all the functions that AMOS has, I'd ask you to check out my book, Applied Structural Equation Modeling Using AMOS. I give you a detailed explanation and example as well of all icons that are in the ribbon on the left-hand side, and all of the icons that are in the menu at the top get an explanation as well. So if you want to know the full functions of AMOS, and some of them, are widely used, some are more kind of specific, you can kind of have a better idea of that. And if you're just looking for more information on structural equation modeling and how to model using AMOS with basic models from confirmatory factor analysis to structural equation modeling in the structural path side or even path modeling, I address that, and even more advanced topics, mediation, moderation, moderated mediation, invariance testing, and many more of those. But that's all I got for today. Good people, I hope y'all have a great day, and if you saw value in the video, I'd ask that you like and subscribe because there's more videos to come.